let's take some time to create a bullet collision VFX particle system. Now I think we can do this relatively quickly because we already have that other prefab for our death VFX that we can kind of duplicate and mimic relatively closely. So I'm going to go into my assets in my prefabs folder and VFX, and I'm not going to copy one of these prefab variants, but I am going to duplicate this base death VFX particle system to give us something to start with. And I'm going to call it my bullet hit VFX. I'm going to make most of this a challenge so you can kind of flex your game dev muscles and get your particle system looking the way that you would like it. But let's get you started in the right direction. The only thing that I'm going to change for now is just this renderer material property. So if I drag this into the scene so we can see what it looks like, I'm going to go into my materials folder, my textures folder, and I'm just going to duplicate this border particle, and I'm just going to change it to the no border particle. And we can use this for our bullet VFX. So I'm going to change this maps albedo field to my particle no border sprite. Over here in my bullet VFX, I will go into my renderer and just drag this no border particle into my material section. Hit play and see what that looks like. Yes, that's looking quite nice. I'm going to go ahead and apply those changes to the prefab, and we'll introduce you to this lecture's challenge. Take some time on your own and create a bullet collision VFX particle effect that looks good to you. And then just make a mental note that this will be instantiated when the bullet is destroyed. So we're really just creating a bullet collision particle effect. But I'd like you to flex your game dev muscles and create something that looks good to you. Take some time, tinker around with the particle system. See if you can find something that looks good to you on your own, and we'll go through the way that I'm going to go ahead and do it when you get back. Alright, welcome back. I'm not going to overcomplicate mine. I just want my duration to be super short, so I'm going to set it to something like 0.05. My start lifetime, I'm going to chop it down to maybe something like 0.2 to 0.4, I think will be about right. My start speed, I do want it quite high, so maybe twice as much as a good starting point. At my start size, significantly smaller, I'm going to do it to something around 0.2. Don't need gravity, not really that important. Change it to 2D because why not? I've got my stop action as destroyed to make sure that particle effect gets destroyed when it's done with its life cycle. And I'm going to change my emission count property to something, maybe just a little bit higher, maybe something like 14 will be about right. Let's see what that looks like so far. Yeah, I think that looks pretty good. Now you can barely see it actually in my game view, but we're firing quite a bullets, and I think that's a good starting point. But I think this is actually really going to come to life when we introduce bloom and some other post-processing effects a little bit later on. But for now, we'll leave it at that. I'll make sure I apply those changes to the prefab, delete that from the hierarchy, and let's go get that set up in our bullet class. So in our scripts folder in gun and in our bullet class, we'll go ahead and open that up. Right here at the very top, I'm going to go ahead and create a serialized field that I'll call private game object, and we'll call it the bullet VFX. And all we need to do is instantiate that when our bullet is destroyed. Now this is getting quite messy, but just as a reminder, we're going to refactor this a little bit later on using interfaces whenever we get to the point where we're also implementing health and knockback and flash logic for our player as well. For now, we'll leave it at that. And just at the very tippy top, let's instantiate whatever I just said it was, the bullet VFX prefab at transform.position at transform.rotation. You could definitely use quaternion.identity for it. Wouldn't really matter. We're not setting any sort of default rotation for either or. So let's leave it at that for now, and let's try it out back in Unity. Let's attach that to our bullet prefab. So let's see, I've got that here, and we'll drag this bullet hit VFX into our bullet VFX field. Let's hit play and see how that looks. Nice. That's already looking pretty good. We have that nice little bullet collision instantiated explosion prefab VFX. Let's keep going and add some more visual effects with our player and how it moves, how it jumps, and how it lands. Before we do that, I'm going to introduce you to a little trick that I probably should have done at the very beginning of this course that's starting to drive me a little bit cuckoo. So every single time we hit play, it's going to compile, reload our domain, complete the domain, and it's going to take quite a few seconds for us to load our game. You know what I should have done a long time ago is teach you this little trick to get rid of that. So if you go into your edit project settings and you come over to the editor section, you can actually scroll down and there's going to be an option for how we enter our play mode. If you enable this enter play mode options, it's actually going to allow you to disable reloading the domain and reloading the scene by default. If it's unclicked, then these are actually on by default. I know that's a little bit counterintuitive, but if you toggle this on, these are going to now be toggled off. And check this out. The next time we click play, wow, that just immediately entered play mode. Sorry about that. We should have done that a long time ago, in my opinion, but we're finally getting around to it. The most important thing to note on why this is a little bit risky is if your game crashes and you hit play and you create some sort of compilation error or crash your game, it's not going to save. So you do have to be a little bit more careful about just making sure you're hitting the Control S key every once in a while. I have a pretty good habit of hitting the Control S key and saving my project before I hit that play button. So with that nice little Unity tip inside of this course, let's move forwards to the next lecture. When you're ready to move on, I'll see you there. Let's create this nice little move dust particle effect when our player is walking on the ground. Now the way that we're going to handle this and things like a jumping or a landing effect is actually with some nested particles directly inside of our player, and then we can toggle to play them or stop them as necessary. So in our player visuals game object, let's create an empty game object, and let's call it particles. Inside particles, let's right-click this and create a new particle system. So effects and particle system, we'll call this one the Move Dust VFX. And this one's going to be pretty significantly different than our others, so let's go ahead and do this one from top to bottom. I'll go ahead and at the very start do what we did before and just change my renderer to that nice no border particle that we created before. So this one, the duration and the looping is actually not important. The thing we can actually go immediately to for explanation purposes is we're going to change our emission not to rate over time, but rate over distance. And I'll show you what I mean by that. So if we actually change this rate over time to 0 and something like our rate over distance to 3, and what this is going to allow us to do is this particle system is no longer going to emit by default. It's only going to emit while it's moving around. So the second we actually stop moving, it's going to stop emitting those particles. So I'm going to make sure that this is set right around at our feet. And then I'm actually going to just start working my way through some of these properties to get the effect we're looking for. I'm going to change my start lifetime and my start speed to both be some randoms and between two constants. And the start lifetime, let's just do something like 0.2 to 0.7. And the start speed, I'm going to do something like 0.5 to 1. And the start size, let's also have some variation. And let's do something like 0.2 to 0.35. Now, I've already played around with these settings quite a bit. You're more than welcome to be creative and tinker around with it as much or as little as you'd like. Or you can continue to follow me at the moment. The moment, that's going to look something like this. We're going to have to hit play. Then we can just move it around and we've got about the right size that we're looking for. Now to continue, I'm going to actually toggle on gravity for this one since it's kind of like, dust popping up and down. And I'm going to change my gravity modifier to 0.1. And that's actually going to move the gravity of the particle down, not up. Now let's change the simulation space, not from local, but change it to world. That way it's not going to move with our player as it's continuing to move. We want it to just spawn up in the world and kind of spawn directly back down. We've got our emission set, and let's change the shape just a tad. So not cone, I'm actually going to use edge, just to kind of get it to spawn directly where the player is. And I'm going to change my radius, just shrink it down about the size of the player, so right around 0.55. All I really did was visually barely look at this little teensy tiny line that you can just barely see spawning by our feet. I think that looks about right. Let's change the size over lifetime. This one I want to be a little bit different. I'm going to be a bit creative, and I'm actually going to kind of spawn it to go up and then down. So the dust is going to kind of poof up and then poof back down. So I'm going to click somewhere in the middle, add a key, shift that up, and just kind of shift that downwards to get somewhat of like a little bit of a natural poofy sort of motion. So I think that's going to look so far. Let's click play, move it around. Yeah, we're already getting close to the effect that I'm looking for. Next, just add a little bit more variation. Let's add a little bit of noise and toggle this noise property on. And that's all we need to do there. I'm not going to change any of these properties. And I think that's it. I'm going to go ahead and leave play on awake for just a moment, just while we play around and see what this looks like so far. Hit play. You can see we've got this nice little particle effect motion while we're moving, which I think is already super slick. Now, a little bit of an issue. I don't really want this effect to play when I'm in the air. I actually only want it to play when I'm grounded to kind of give that visual effect of walking. So let's go ahead and manage that through a custom C# script. Personal preference, I think that was a little bit too small for me. So I'm going to change my start size to something just a little bit bigger, maybe something like 0.3 to 0.45 ought to do the trick just fine. In our scripts folder, in our player folder, I'm going to create a new C# script, and I'm going to call it player animations. Because now all we need to do is toggle this off and on as appropriate. So on our player game object, I'm just going to attach that player animations class that we just created as I collapse all these just to clean it up, and add my player animations class, and I'm going to drag it up by my player controller since they kind of seem to be somewhat related. Let's go ahead and open that up in VS Code. Now we're going to add quite a few things to this player animations controller, so let's just add one at a time. And let's start with the one that we just created. So let's create a private serialized field. It's going to be a particle system, and that's going to be that move dust VFX that we just created in our hierarchy. And all we need to do is in update, just check if we're grounded or not. Well, that's convenient because we already have that function in our player controller. So let's just create a private void detect move dust function, and then we can just tap directly into our player controller. But I think in our player controller, we just need to change our isGrounded function to public to make sure that we can access it in our player animations. So with that created, let's go ahead and fire that in update. And down here in detect move dust, let's just check if we're grounded. If we're grounded, we'll go ahead and fire off that dust effect. So let's just check if player controller .instance.check grounded. And if it is, let's just make sure first that the move dust VFX is not playing. So the way that we can do that is go into move dust VFX, and we can check if it's playing. If it's not, well then let's play it. So move dust VFX play with a capital P. Else if we're not grounded, then we want to do the opposite. We just want to stop it. But I also do want to just copy some of this logic and check if we're playing or not. And we'll do the opposite. So I'm going to copy and paste this down below, get rid of this exclamation point, and then if it is playing, then we just want to stop the particle effect. And with that, I think we're set to go. Let's try that out back in Unity and see what it feels like. On our player animations class, let's just drag in my move dust VFX particle system. Click play and see what that feels like. I'll open up my game view. Nice, we've got that move dust VFX particle effect working, and as soon as I jump, yep, and then I'm in the air and it stops, and once I land back again, it kicks right back up. Yes, I think that's already adding quite a bit of visual feedback for the user. Next up, let's get our player tilting back and forth depending on the direction that we're moving. When you're ready to move on, I'll see you in the next one. In this lecture, let's get our player leaning back and forth while it's moving both in the air and on the ground, depending on the direction that we're moving. Now, the way that we're going to do this is by moving and rotating the player visually. So we don't actually want to move the entire player all at once. We just want to move this character sprite and everything that will be eventually nested inside of it. So, for example, all we really want to do is move this Z-axis back and forth as necessary depending on the direction we're moving. So let's get that rigged up in our player animations class. Keep in mind we are going to need the input to handle that properly. So if we open up our player input, we need some sort of way to get this gather input move value. Now, if we were to go through the entire process of getting this gather input struct back in our player animations, I think that would be a bit few too many steps for me. So the way that I'm actually going to do that is just grab it from our player controller directly. So if we create a public getter for our move input, specifically our frame input.move value, we can get that value directly from our player controller since that's where it's really centralizing our input at the moment. So I'm going to create a public vector2, and I'm going to call it my move input, and I'll use the arrow syntax to return my frame input.move value since we know that's going to return a vector2. With that set up, we can now easily use this value in our player animations. And we're going to need a couple different things. Let's use a serialized field for a private float for the amount that we want to move and rotate on our Z-axis. So let's call that the tilt angle. And I'm going to initialize it to something a bit probably too much at the moment to exaggerate it and make sure we can see it right out of the gate. And another serialized field for a private float that I'm going to call my tilt speed. Now we are going to lerp this back and forth eventually, so eventually I'd like some sort of serialized field to modify that in the inspector for how quickly we'd like it to lerp. So I'm going to initialize that to something like 5F at the moment. And right below our detect move dust method, let's create a private void, apply tilt method. And we can fire that in update as well. So let's call apply tilt in update. We need to gather basically if we're moving left to right or standing still. And then find that target angle. So if we're moving left, we want to tilt one way. And if we're moving the other direction, we want to tilt the other way. So we need some sort of if check statement. So I'm going to have a float called target angle. And then depending on if our player controller .instance.move input that we just created, if that's less than 0, then let's just make our target angle equal to our tilt angle that we defined up top. Else if our player controller .instance.move input.x, if that's greater than 0 when we're moving the other direction, then I'm just going to actually lean the other way. So I'll duplicate that line, move it down, and then I'd like to just apply my negative tilt angle. Now, I'm just realizing I misspelled tilt, so I'm going to go ahead and click this, click F2, and rename them all at the exact same time, and just rename that appropriately without the typo to tilt angle. Did I get the tilt speed right? Okay, good. At least we're good there. Whew. Else, if we're not moving at all, then I just want my target angle to be 0. So I essentially want it to move back to just straight up and down. Now, quaternions can be a bit tricky, so let's break this down one at a time. So I'm going to grab the quaternion of where we're currently angled at. So I'm going to call it the current character rotation. And I'm actually going to grab that player sprite directly as a serialized field. Because I don't want to move the entire game object, I just want to move the sprite. So I'm going to make sure I set that as a serialized field up top as well. And it's going to be a transform since we're just going to rotate it directly. And I'll call that my player sprite transform. Now with that, I'll copy and paste that down below because I just want to grab my player sprite transform rotation. And let's figure out how we want to adjust our quaternion using quaternion.Eulers. Now that's always helpful because we can actually think of it in a human sort of way with an X, Y, and Z value. So here's how we set that up. We go quaternion.target rotation. Let's call that target character rotation to follow similar naming convention. And we'll set that to be equal to quaternion.Euler, and then we can just plug in the X, Y, and Z values. So we do need to grab the current rotation.Euler angles.x value of our character, and then we need to do the same for the Y value since we're not moving either the X or the Y value. So I'm going to break this down on a few different lines. You don't have to do it exactly like this syntactically, but I'm just going to do it to make sure we can all see it on the recording. And I'm going to copy this line here, and I'm just going to make sure that's my Y value. And let's see if we can squeeze it in here. I'm trying to set it to my target angle. Nice. I think that looks good. I think we can all see that just fine. Hi, Steven from the future here. Now this might be one of the silliest typos I've ever made. You can see my second quaternion. I've labeled it with the lowercase q. Now that's just quite a bit of a coincidence that it works. I must have hit some sort of hotkey. At the very top of my class, I actually probably hit some sort of hotkey and imported the Unity Engine mathematics namespace to make sure that I'm not getting any sort of compilation errors. So I'll fix that in the next lecture, but just make sure that your quaternion for your target character rotation is a quaternion with an uppercase Q. And with that target character rotation set, all we want to do is set our player sprite transform.rotation. And the way that we can move that, we're not going to lerp it quite yet, but let's just make sure everything is working correctly. We just set our player sprite transform.rotation equal to that target character rotation that we just set. Nice. Let's go try that out back in Unity and see what it looks like. I'm going to go ahead and select my player in the hierarchy. And then over here, we just need to drag our player sprite transform over to the field that we chose. Now, I chose character sprite and player sprite. I'm just going to go ahead and rename this to my player sprite. I feel like I should do it the other way around. You know, let's go change this player sprites transform. Let's just rename that to character sprites transform. That might bother me just a tad. So with that, I'm going to go ahead and F2 and then just rename this to character sprite transform. I'll hit enter and I'll head back into Unity. Let's go ahead and drag that in one more time. Let's hit play and let's see what that feels like. All right. Yeah, looking good. We've got that correct lean going back and forth kind of in the opposite direction with the direction that we're moving, which I like quite a lot. I think that already looks a bit more natural. Next up, let's set that up to lerp, and I think that'll make a great lectures challenge. Inside our apply tilt method, go ahead and set it up so that our lean lerps back and forth appropriately so that it's not an instant snap. Get that lerping back and forth, give it an honest effort, pause the video, and I'll see you back here in a few moments. Alrighty, welcome back. Now the way that I've done it, so instead of using this target character rotation here directly, I would just like to lerp it using quaternion.lerp. So what do we need to lerp? We need to lerp A to B and over what sort of time frame? So where are we lerping from? That's our current character rotation towards our target character rotation. And then how quickly do we want to do that? We want to do it by our tilt speed times time dot delta time. And we'll go ahead and close that off. Now I'll bring that down on one line so that we can all see it together. And just like that, I think we're looking pretty good. Let's go try that out back in Unity and see how it feels. Nice, we're in business. I like how that's leaning back and forth depending on the direction that we're going. It doesn't really matter if we're in the air or not. I like the way that that looks and feels. Now it is leaning a bit too much subjectively for my taste. So all I'm going to do is I'm going to go into my player and just change this tilt angle to something like 20 to 14, I think should be about right. All right, well done on this lecture. When you're ready to move forward, I'll see you on the next one. In this lecture, let's get our cowboy hat sprite moving and leaning in the opposite direction of our player to add that extra little bit of oomph to the way our player looks and feels. Now I'm going to structure this entire lecture as a challenge. So go ahead and achieve the look we just gave in the preview. Lean our cowboy hat according to how we're moving. So let's go ahead and show it one more time. We have our cowboy hat sprite inside of our player game object, and then we just need to, in our apply tilt method in our player animations class, add some additional logic to get our player hat moving in this sort of direction that we're looking for. Now I think this is a pretty fun and unique challenge to improve your game dev skills in a way that if you were working with a game designer and they said, hey, we want to achieve this sort of look, it's up to you as the game dev programmer to go and achieve that look in code. All you really need to know for now is that the cowboy hat sprite can be found in your sprites folder inside of the player folder. Go ahead and pause the video, give it an honest effort, and when you get back, we'll go through it together. All right, welcome back. Let's go through this together. Inside of my player game object, inside of visuals and then character sprite, I'm going to go ahead and right click and create a new empty game object that I'll call my cowboy hat. And in here, let's add a sprite renderer. Now, I know that it exists in my project directory as cowboy hat, so I'm just going to search for it manually and add my cowboy hat. With that created, I'm just going to go ahead and scroll it up to about right there, I think looks about right. And let's go ahead and open that up in VS Code. So what am I going to need? I know I'm going to need two different things the way that I'm going to achieve this. I'm going to need my cowboy hat transform, so I'll duplicate that line there, and I'll just say cowboy hat transform. Now this is a bit of extra credit bonus, but if you noticed, the hat was leaning and lerping just slightly faster than the way the player was leaning. So I'm going to go ahead and add an additional float. I'll just drag it down here to the very bottom, and we'll call this the cowboy hat tilt modifier. And I'm going to set that to something like 2F. Hey there, Steven from the future. Did you catch that little typo? I typed cowboy boy. Oopsie. Now it should just be cowboy hat tilt modifier. Go ahead and fix it if you'd like. And I'll show you how I apply that down below. Now this is very, very similar logic to what we're doing here, so I'm actually just going to go ahead and copy and paste all of this. Wow, I actually have 2 semicolons here and I didn't get a compilation error. What a fun thing. Oh, and you know what? Before we forget, let's go ahead and fix this typo as well that I created in the previous lecture, but I know I mentioned it already, so I'll just go ahead and fix that typo. And then here at the very top, we don't need this Unity Mathematics namespace, so I'll go ahead and delete that for now. So let's go ahead and copy and paste all of this logic, and we can go ahead and do the same. So I'll just make a little note and comment here and say player sprite. And then down below here, we can say this is our cowboy hat sprite. Instead of our character, we'll go ahead and grab our current hat rotation. Instead of our target character rotation, we'll grab our target hat rotation. Instead of grabbing our character sprite, let's grab our cowboy hat sprite, which we call the cowboy hat transform. And then we can just go ahead and copy this and then change these two X and Y values. I'm just going to go ahead and click one, double click here and then Control D twice to change both of these all at the same time. Paste that on in, and we're set to go with the previous logic. With that copy and pasted, let's grab our target hat rotation and we'll paste this in place of our target character rotation. And where do we want to put that modifier? I'm going to put it in two different areas. Now we actually want our hat tilting the other direction, so I'm going to change this to a negative, and then I'm actually going to divide it by my cowboy hat tilt modifier. Since I don't want it to tilt too much, I'm just looking for a nice little subtle effect on my cowboy hat. But I do want it to tilt faster. So we can actually just use this exact same modifier, and where we say times delta time, we can say times cowboy hat tilt modifier times time dot delta time. Nice. I'll go ahead and just zoom that out just a little bit for just a second just to make sure you can see everything. With that all set up, let's go ahead and test that out back in Unity. Let's make sure we assign our cowboy hat appropriately, and we'll just drag our cowboy hat into the cowboy hat transform. Let's hit play and see what that looks like. Oh boy, looks like we did something wrong. Alright, let's go ahead and try to debug that together. I'm going to head back into my player animations. It looks like everything is assigned properly. We got our cowboy hat. Good, good, good. Alright, heading back into my player animations. Let's see what we missed. Right here. It looks like I didn't change it to actually rotate the hat directly. We want to grab this cowboy hat transform, and instead of rotating the character sprite transform twice, we want to rotate the cowboy hat. Alright, with that fixed, let's try that out back in Unity one more time. Alright, there we go. I've got my nice little cowboy hat moving and tilting back and forth, and I think that adds that nice little bit of extra oomph to give our character just that much visual feedback to feel real good. And you know what? I quite like this effect. It almost looks like some sort of mafia member with his hat pinned down like this. I like that a lot. Alright, well done on this relatively short lecture. When you're ready for the next one, I will see you there. In this lecture, let's rig up a jump effect similar to how we did with walking to add a little bit of visual feedback to every single time we jump. Let's rig that up in a very similar way to how we did with the walking effect, except it's going to be a very different particle system. So in our visuals and in our particle game object, let's go ahead and create another particle system. So in our particles game object, let's right click, create another particle system. And I'm going to call this the Poof Dust VFX because we can use this for both jumping and landing on the ground if we hit the ground at a certain velocity. So with that completed, let's go immediately scroll down to the bottom of the renderer because I think the biggest teaching point here is I'd like to introduce you to using this texture sheet animation field. So I'll go ahead and toggle that on. So just following along and just watching for just a second, in our sprites folder, in our player folder, we have this dust clouds animation sheet. And if you open up the sprite editor, you can see that we have three 16 by 16 sort of pixel sheets. Now we can actually use these as the texture sheet animation for our particle system. So the way that we do that is we go into our assets folder, materials and textures, and let's add a new material. In here, let's call this the Poof Dust Particle, and we'll set the shader to particle and our standard unlit shader. We'll change the rendering mode to fade, just like we did before, and we'll change this albedo maps section to that dust sprite sheet. So with that selected, let's go ahead and drag that in normally into that renderer section of our Poof Dust VFX. So scrolling down into the renderer, let's just go ahead and drag that in. Now that obviously looks a little bit goofy. So here's what we can do. In our texture sheet animation, we can come over to the tiles and X section and just say, hey, there's 3 tiles. And there you go. Just like that, we actually have the dust particles animating through those 3 texture sheets, which I think is super cool. We can even do things like if we want to be fancy with our frame over time, maybe we want the first one to just last a little bit longer and kind of come up, have this sort of come down, and that adds a little bit of visual variety to the way that our texture sheet animations are changing from tile to tile, which I think is super cool. I don't think we need to add anything else to our texture sheets. We can go ahead and close that. Well, let's make sure that our sorting layer is VFX, and then we'll just change that to the order layer of 1 to make sure that it appears above our splatter effect. Nice, and then let's start from top to bottom and change whatever else we might need. I'm going to change my start lifetime to a random between 2 constants, as well as my start speed, as well as my start size. So just as we did before, let's add a little bit of variation to that. Now, I don't want it to be looping, I don't want it to play on a wake, and then I just want the duration to also be super short once again. So I'm going to set that to something like 0.15 ought to be about right. I'll set my start lifetime at something like 0.3 to 0.5. My start speed at something like 2 to 5 I think should be about right. And then my start size, let's change it to something like 1 to 1.5. Now again, I've already played around with these values a bit, but this will get us pretty close to the effect that we're looking for. Let's go ahead and see what that looks like so far. Nice. We don't have nearly enough particles, but we're off to a good start. Let's change the gravity source to 2D physics and change the simulation space to world. Now, I kind of want to actually play around with the local and world. I'm not actually sure what might look better, but let's start with world and see what that looks like. Change the gravity modifier to 1 just to kind of get it downshifting right away. Let's head over to our mission and then just change the rate over time to something like 50, and we'll see what that looks like. Yeah, I think that's enough particles to work with, except we just want it to spawn at our feet. So I'll go ahead and click this, shift it down a bit. I don't want it all the way at my feet, so maybe something right about here at the bottom center of our player. And I'll go ahead and change the shape. Now we could use an edge. I'm going to use a box just to be a little bit different on this one. And then we can just go ahead and shape this box using the editor tool. So I'll click this and then just kind of want it to look something like this. Spread it out just a tad and we'll see what that looks like. Yeah, there we go. I think that's already looking pretty close. Now on the others, we shrunk it over time. On this one, I think I'd like it to just fade out. So let's do color over lifetime. Let's click this, open this up, and then just kind of change it. So if I click the top right tool where it's dealing with alpha transparency, I'm just going to drag that all the way to the bottom. And if we click play, we can see it fading out over time. Now that's fading out a little bit too quickly, subjectively for my taste. So I'm just going to right click, create another key, and then change the alpha transparency to not fade out so fast. So maybe something right around there. Yeah, I think that looks pretty good. I'm going to maybe just widen that just a tad, and I think that looks about right. We could edit it forever and ever. I'm going to shift it up, but I'm going to call it good there. I think it might be just a little bit too many dust effects for me, so change to my mind. Let's go from 50 to 40, and we'll call it good. Yeah, I think that looks about right, and let's move on. Now, unlike our move dust effect that's only moving when we move, we can actually just go ahead and play this particle system directly when we jump. And I think that'll make a great challenge. So go ahead and rig up our jump effect particle to play every single time our player jumps off the ground or a double jump. It doesn't matter. In our player animations class, you'll just want to subscribe to our on-jump action that we already have created in our player controller. So go ahead and plug into that as accordingly. We already have the skeleton set up, so all you need to do is set up a custom method to set up that jump effect, subscribe to the on-jump action, and you're all good to go. Go ahead and give that an honest effort. Pause the video, and I'll see you back here in a few moments. All right, welcome back. In our player animations class, let's go ahead and I'm going to duplicate this particle system here, and I'll just call it my Poof Dust VFX. Let's go create a method to fire that particle effect. So I'll call it private void play poof dust VFX. And all we need to do in here is go into that poof dust VFX dot play. And that will play it every single time we call this method. When do we want to call that method? Well, we want to subscribe to our on jump action in our player controller. So how do we do that? We go and subscribe to it in on enable, and we can go into our player controller. And just to verify what that looks like, let's go into our player controller, and I believe, yep, great, it's a public static event. So we can just go into our player controller class directly and subscribe to the on jump action. And what do we want to subscribe? We want to subscribe to this play dust poof effect. So we'll go ahead and do that, duplicate it, and unsubscribe to it and undisable. So I'll just change this to a minus sign. Nice, let's go try that out back in Unity. Let's drag that on over into our serialized field. Blow up my game view and we'll see what that looks like. Jump and jump. Yes, you know what? I like that quite a lot. I kind of like using the world space instead of local space. That way when you jump, it kind of leaves that dust effect behind instead of following the player. I think that looks really good. All right, well done on this lecture. When you're ready to move forward on to the next one, I will see you there. In this lecture, let's rig it up so that if our player hits the ground at a specific Y velocity, we both screen shake a little bit and fire that same poof dust particle effect. Now we've rigged up screen shake before, and how do we do that? We just do that with a Cinemachine impulse source. So let's actually add a separate one to our player directly. So I'm going to go ahead and add this Cinemachine impulse source. Now you'll notice I already have another Cinemachine impulse source component attached to my player, and that's just fine. We can have multiple impulse sources with different settings. Now before, if we just go peek at our gun and how we did that, we used a recoil with a really short little time and a very small default velocity and just a little bit of a kickback in our Y. So I think if we do something a little bit different in our player impulse source, we can actually do something like an explosion. Now this isn't actually an explosion, but this will give that sort of shake sort of ground effect that you might expect when you were hitting the ground at a high Y velocity. So let's set the time to something like 0.22, the X value to something like 0.06, and then the Y value probably ought to be just a tad higher. So let's do something like 0.08. And if you click play, it'll let us test that to see what it looks like if you hit invoke. Now that's super subtle. Subjectively, I think that's what looks good to me. Let's go rig that up in code in our player animations script. So what are we going to need? We're going to need some sort of float to detect how fast we're hitting the ground in the Y direction. And if that is exceeded, then we want to both screen shake and fire that particle dust effect. So let's create a private float and let's call it the Y land velocity check. So velocity check. And let's start something a little bit small. So around negative 10F, and we'll do a little bit of testing to see what that looks like in Unity. So we're going to need another private float that we can cache as a reference for our current Y velocity. So let's create that. Let's do that as a vector 2, and then we can just grab the Y float value from that vector 2. So let's call it velocity, and I'm going to call it velocity before the physics update. Because this is a little bit tricky. We don't actually want the velocity when we hit the ground because then it'll be 0. So we actually need the frame directly before it. And the way that we can grab that is actually in fixed update. So let's go ahead and do that. So right here, let's create a fixed update method. And all we want to do is change our velocity before physics update equal to our rigid body that it looks like we haven't created yet to our rigid body velocity. Well, let's go ahead and grab that rigid body reference. So a private rigid body 2D, we'll call it rigid body just as we did below, and grab that on awake. So rigid body equals get component rigid body 2D. Cool. Now with that set up, we actually have that reference. Let's just see what that looks like in Unity. So let's add a little bit of a debug.log and debug that velocity before physics update just to kind of see what we're working with back in Unity. So let's go test that out. So if we hit play, open up our console, we can see that when we're on the ground, our Y velocity is 0. And when we're hitting the ground, we're about at, let's see, negative 13 or so from a single jump. Now, I don't want my dust effect to spawn on a single jump. I only really want it to spawn if we're jumping off of a ledge and we actually hit the ground at a specific velocity. So I think something closer to maybe like negative 20 is probably going to be about right. Let's go set up the logic to fire all of those effects back in our player animations script. So let's leave this debug.log up for just a minute, and let's create some logic to detect that collision. Now, I think the best way to do that would be with an on collision enter 2D. Now, a little bit later on, we might actually need to check the layer of what we're landing on. I'm not really sure if it would look good if we land on enemies or not, but let's leave it at that for now. And let's just check our velocity. So if our velocity before physics update is less than our Y land velocity check, then we want to play our poof dust VFX method as well as fire that impulse source that we created. So let's go ahead and grab that private Cinemachine impulse source. My VS Code set up in a way that when I use this, it will automatically import this using Cinemachine namespace. And I'll just call it impulse source with a lowercase I. And then we'll grab that on awake. So impulse source is equal to get component Cinemachine impulse source. Nice. Oh, and silly me, looks like we're getting a compilation error. I actually don't want just my velocity of my vector 2. I need the Y value from that vector 2 to compare a float to a float. And then we can go into our impulse source and dot generate impulse. Nice. Let's go see what that looks like back in Unity. If I'm not mistaken, I think we have everything set up. Yep. If we do a single jump, it doesn't actually spawn that visual effect. That's great. That's exactly what I want. But if we jump off something just a little bit higher, get that velocity perfect. We get that little bit of a screen shake and that land effect. Let's try that one more time. Boom. I think that looks great. You can go ahead and tinker around with those settings to get an effect on what you're exactly looking for. But for now, I'm satisfied with what that looks and feels like. When you're ready to move forward to the next lecture, I'll see you there. Hello and welcome back. In this lecture, let's create a little bit of post-processing in Bloom using a shader graph to increase the HDR value of some of our sprites to give us this nice, cool glow effect. And because this scene is already set up to work with 2D URP settings, this is relatively quick and easy to set up the baseline to get this going. All we need to do is go into our hierarchy and let's create an empty game object. And let's call this our global volume since we're only going to have one in this scene currently. Let's add a volume component. And since I don't believe we have one created yet, let's go ahead and hit this new button. We can just call this the global volume. I think that's just fine. And on it, let's just actually try a little test and add a vignette to our post-processing to make sure it's all working. All we need to do is toggle on this intensity, scroll it up to see if it's already working on our main camera, and yes, we are in business. I'm just going to add a little bit of subtle vignette. I don't think I want too much. I think that's a good start to work with, as well as maybe just a little bit of a color adjustment that we can tinker around with as well. We don't need to do much here. We're largely going to be focusing on bloom. You can play around with the other settings. In my opinion, there's not a lot to do as far as a 2D pixel game is concerned when it comes to basic post-processing outside of bloom, but let's just add a little bit of a subtle color adjustment as well. I think all I'd like to do is maybe just switch my saturation up just a tad, maybe my contrast up just a tad. Nothing too crazy. You can barely see it even if I toggle it on and off, but I think I'd like a little bit more saturation when it comes to the pixel sprites on screen. Now for the big one, let's add bloom. And this one can be a little bit trickier. You can see if we toggle on our threshold and intensity, and you ramp the intensity way up, everything starts to glow just a tad. But I only want certain things to glow based on the HDR value that we set at a relatively higher threshold than the base threshold. So let's just say something like 1.4 for the threshold. That way, if I ramp my intensity all the way up, well, nothing's going to change. And that's because the threshold is too high. So the way that we need to set this up is with a basic shader. So let's go into our assets and our materials folder and let's create a new folder that we can call shaders. In here, let's go ahead and open that up. Let's right click create. Let's find where it says shader graph, go into URP, and we're going to create a sprite unlit shader graph. Let's go ahead and get that created. And let's just call that my sprite glow shader. Let's go ahead and double click that and open up our sprite glow shader graph window. I'm going to double click my tab to blow up my window completely so we can see what we're working with. Now, if shader graph is something that is intimidating to you when you first open this window, I don't blame you one bit. I've been there. I'm not a shader graph person myself. Now, this is the only shader that we're actually including in this course. However, if this is something that you just don't really want to be bothered with, I've gone ahead and included this specific shader directly as a resource that you can download in the Resources tab. Now, just in case you don't have this Blackboard or this Graph Inspector, you can just toggle these buttons here in the top right to both toggle your Blackboard and your Graph Inspector accordingly. Let's start setting up the base to get this really simple shader graph set up so that we can achieve attaching an HDR value to a material that we can attach to our sprite, allowing us to achieve a relatively simple bloom glow effect. Now, shader graph is an entire whirlwind of a topic in and of itself. There are entire courses based on just shader graph. So all we're trying to accomplish is two things. We need a way for our color to expose an HDR value. So we can go ahead and set this up. Let's hit the little plus icon. We'll scroll down to color. We'll just call that color. That's just fine. And when we click that over here in the top right or wherever you have this window, you can keep the naming convention for this the same. But what I would like to do is come down to my mode, and instead of default, I want to change this to HDR. This will allow us that in the inspector, when we get back into the normal Unity view, you can click and change this color and it will expose this HDR value of intensity. So by default, let's leave it at 0. Let's change it to white, and let's change our alpha transparency to be all the way up by default. Next, let's add another texture 2D, and let's just call this main text with T-E-X, no T at the end, main text for texture. Let's click that, and with that clicked, just make sure that your reference naming convention is underscore main text with this exact name spelling and capitalization. And this is all we need. This main text field is going to allow us to set specific sprites if we need them in the inspector, so that'll make a bit more sense in just a second. For now, let's drag this main text field in. We can highlight both of these nodes and just shift them over to give us a little bit of space to work with. And clicking and dragging this little circle, we can drag on over here. and create a new node, and we just want to look up sample texture 2D. We want to take this RGBA value, drag it over here, and create a multiply node. Now we don't want to go into B, we actually want to go into A, and in B, that's where we want to add our color HDR value, which we can also change the actual RGB values as well. So we're going to take this little color property, we're going to drag it into the B slot. And you know what? We're almost done. This is actually all we need to do for a basic shader graph. We just need to take our A alpha transparency value from our sample texture 2D, plug it into this alpha transparency property over in our fragment node, take the out value from our multiply node, drag it into base color, and voila, we are done. That's all we need to do to create some materials in Unity to add that HDR value to it to allow it to glow. Let's go ahead and in the top left, make sure you save your asset, and then I'm going to just double click this window to minimize it back down. Now let's give us something to play around and work with in the scene, and I think the first thing that I'd like to do is modify our bullet material to glow. So I'm going to go into my Assets, Prefabs folder, Player, and I'm just going to drag a bullet into my scene to give us something to look at. All we need to do is add a new material to this. Currently we're just using the Sprite-Lit default material. So in our Materials folder, in our Shaders folder, now we actually can just right-click this Sprite Glow shader directly and create a material from it. And let's call this the Teal Glow. Now you can name it whatever you'd like, but I'm going to make my bullet grow a nice little subtle teal color. So I'm going to call it the Teal Glow. With that selected, you can actually see these two properties that we have. Now for the bullet directly, we don't need a texture. That's just fine. We'll introduce what that means a little bit later on for things like particle systems, should we need it. But in our color property, if you click this, you can now see that HDR value and the color property, but let's actually attach it to our bullet first so you can see it in real-time action. So I'm going to click my bullet prefab in the hierarchy, and I'm just going to grab my Teal Glow material and drag it into my material field. Let's go back to the material and actually change some of those values. So with our material clicked, we can now start to change these intensity values directly. Now I'm noticing my post-processing effects aren't exactly working. I probably toggled something off. So let's go over to my global volume, make sure that my vignette is ticked on. Not sure how that got unclicked. And then we are going to need to make sure we have some sort of base intensity on our bloom effect. So let's set it to something like 3 is going to be about right. We can tinker with it a little bit later on if we need to. Now with our bullet having this Teal Glow material, we can click the color property of our bullet and ramp up the intensity, and we can actually see it starts to glow accordingly. Now, I don't want to get too overboard, so maybe something like right about there is about right. And I'm just going to create a nice, subtle teal sort of glow. I think somewhere around there looks nice. Maybe ramp up my intensity just a tad to something like right about there, I think looks nice. Yes, very cool. Let's go ahead and apply that to the prefab. Delete it from our scene. Let's hit play and see what that looks like. Nice. I think that looks a lot better already. We have a nice, very cool, subtle glow effect attached to our bullets. Now we can start to attach it to whatever we'd like, but for now, the only other thing I'd like to attach it to is this bullet hit particle system. So let's go ahead and do that. So Assets, Prefabs, VFX, find my bullet hit VFX. I'm just going to scroll down here to my renderer, and instead of the material being this no border particle, I'm just going to select my Teal Glow material. Let's hit play one more time and see what that looks like. All right, that looks a bit sci-fi-y, so it's not quite fitting the theme of our mafia sort of hat, but you know what? I quite like it. Let's actually just show you one more quick example before we move on. Now let's say you wanted to add a little bit of bloom to your enemy death VFX. Now that one can be a little bit trickier because if you were to actually just add that same material we created, and let's hit play and see what that looks like, it's not going to actually have quite the right shape. You could see that it's just a normal, boring little square, and that's because it lost the shape of the sprite that we had attached to it before. So if you click this, let's just for example say you double clicked it, and let's just call it the enemy death glow particle. I'm actually going to delete this. I'm not actually going to do this, so I'm going to delete it in just a second. But to show you an example of why this main text field is relevant, you can now select this main texture should you need it. So if I chose the particle, and I chose the one with the border just like we had before, now we can attach this material to the enemy death VFX prefab. So enemies VFX, enemy death VFX, and attach that directly. I already forgot what we called it. Oh good, it was called the enemy death glow particle. And with that created, now we should actually get the correct shape when our enemy dies, which we just saw there. Now, it's not quite the effect I'm looking for, albeit it actually does look kind of cool. So I'm not going to worry about it for now. I'm just going to use a standard material and not actually have my enemy death glow, even though I do think it's quite cool. So I'm just going to keep my border particle selected, and I'll delete that material from my shaders folder. So the enemy death glow, we'll introduce maybe something a little bit later on for something else, but for now, I think that looks quite good. So with that created, well done on this lecture. We've now introduced a little bit of bloom and post-processing to our game. When you're ready to move forward and add some more game feel sort of effects, let's move forward and I'll see you on the next lecture.